All right, hey everyone. We are getting into Monday, hello, October 14th, and we are picking up where we left off. Now, if you're in my class, you didn't finish dilation, so I provided a video for you, and the sub will give you that link as well, and you'll be able to see it in your class notebook. And it'll be in Canvas as well for you. But today we are also going to explore dilations in area. So before we get into dilations in area and perimeter, I recommend that you start with the dilations notes that we did not complete on Thursday. So what I want you to do is go ahead and do that. And then after that, just a reminder, you have a spiral that's due Friday. There's due most Fridays. And your minor is going to be due on Thursday, but we'll assess that when I get back on Wednesday. So we'll see. But today we are going to look at dilations and how scale factor affects perimeter and area, or area, sorry. So let's go ahead and look at this first one. This first example. Um, the effects of area and perimeter discovery. So it says using blocks and tiles. We don't have blocks and tiles, but we can do this by drawing as well. It says record the area and perimeter for each rectangle. So this first rectangle that we have is a 2 by 3 rectangle. So we have something like this, and you have one. This is a 2 by 3 rectangle, right? The perimeter of this 2 by 3 rectangle, this is 2, this is 3, this is 2, this is 3. We know the perimeter here is 6 plus 4, which is 10. Okay? The area of this rectangle would be 2 times 3, which is 6. Okay? Now, what would happen if we applied a scale factor of 2, which means we're going to dilate this thing? So this now becomes double the size. So we have 1, 2, let's see if I do this right. We should have like that, right? So we now have 4 by, scratch that, I drew a bad picture. All right, we're going to draw a better picture. And we need to make a 4 by 6. So we need 1, 2, 3. So we have 4. And then on this side, we need 1, 2, 3, 4, 5. All right, so when we draw all of these, we should be able to see, it's not going to be a perfect rectangle, but 1, 2, 3, 4, 5, 6. Okay, and then 4 here. Okay, so now if I look at the perimeter of this square, by a scale factor of 2, this has been doubled. So we have 12. 6 plus 6 is 12. 12 plus 8 is 20, right? Now, here's where it gets interesting. The area is not times 2. The area of this rectangle is 24. So what happened from scaling up the perimeter to the new perimeter? We can see the perimeter was doubled, right? So the perimeter was doubled. But what happened to the area? Did the area double? No, it was multiplied by 4. Okay, so the area was increased by 4. Was increased by 4, sorry. So that's a little bit different. So let's look at another example here. We have a 3 by 5, and in our 3 by 5, see if I can draw this nice. That 1, 2, 3, 4. So that's a 3 by 5. We know that the perimeter of this would be 10 plus 6. If I add all of these up, right? That's 16. And the area of this rectangle would be 3 times 5, which is 15. Okay. If I were to draw a scale factor of 4, that means each of these sides, and I'm not going to draw all of those little squares in here because I don't have time for that. But if I multiply 3 times 4, I know that that's going to be 12, and I know that this side is going to be 20. Okay? So the perimeter of a rectangle with 12 and 20, I'm going to do some quick math here. We have 2 times 12 plus 2 times 20. So that would be 24 plus 40, which would be 64. Okay? So my perimeter is 64. Then I need to figure out my area. My area in this case would be 12 times 20. Okay? 12 times 20 would be 240. Okay? So this time what happened? We went from 16 times 4 to get to 64. Okay? So I'm going to write that. 16 multiplied by 4 equals 64. But 15 times 4 does not equal 240, right? So this time it wasn't multiplied by 4. It wasn't multiplied by 8 either, right? So this time it was multiplied by 16. All right, we're going to see if we're going to figure out some patterns here. But this one is, we know 15 times 16 equals 240. Okay, so my scale factor is here, and my scale factor is here. So what's happening? There's something very different happening from perimeter to area, but it's getting a much larger number every time we apply scale factor to area. So let's look at one more pattern and see if we can come to a conclusion. Okay, we have 9 by 3. Okay, so we have 9 by 3. We know the perimeter of this would be 18 plus 6. Okay, 18 plus 6 would be 24. And the area of this would be 9 times 3, which is 27. Okay, now it says, what would the new dimensions be if the scale factor was dilated by 1/3? Well, that means we're going to multiply both of our dimensions by 1/3, which means 9 times 1/3 would be 3, and 3 times 1/3 would be 1. Okay, so our perimeter would be 6 plus 1, 6 plus 2, which would be 8. Okay, and our area would be 3. So that's interesting too. So we notice now that our perimeter scale factor, we can see that 24 times 1/3 is equal to 8, but 27 times 1/3 is not equal to 3. 27 times 1/9 equals 3. Okay, so once again, we're looking at something that's happening to our scale factor where it looks different. Okay, so then I think this will be my last one, and I'll let you guys work through the rest of them so you can kind of figure out this pattern. But this guy is a 10 by 4. Okay, I have a 10 by 4 rectangle. Let's call this one 4 and this one 10. So 20 plus 8, the perimeter would be 28. Okay, and the area would be 40. If my scale factor is 0.2, that's the same as 1/5, right? So these numbers are not the most friendly. So what could I do to make these numbers work for me? I might have some decimals, and that's okay too. So we would know that 4 times 0.2 would be 0.8. Okay, so decimal 8. Okay, and then 10 times zero point 0.2, so 10 multiplied by zero point 0.2 would be 2. Okay, because it's 2.0. Okay, so then if I were to multiply this out, I have a perimeter of zero point 0.8. Okay, so you got 2 plus zero point 0.8 plus 2. So that's 4 plus 1.6, which would be 5.6. Okay, and then we have the area, which would be um, zero point 0.8 times 2, which would be 1.6. So that's interesting too. So that means that our area is much smaller once again. So it's time to get to a conclusion here. We've went through a few of these, and I want you to do the rest of them so you can get the pattern. But this is what I want you to know. When we find perimeter, when we apply scale factor to perimeter, so the scale factor for perimeter is multiplied by the scale factor. It's just itself. So let me give you an example. Um, let me pause this for a second. Scale factor for perimeter, sorry about that, is just multiplying by the scale factor. Okay, by the scale factor. Whereas, let's do it this way so you can see. But scale factor for area is multiplied by the scale factor squared. Okay, so let me draw a line here. So scale factor for area, I'm just going to write the letter A, is multiplied by scale factor squared. Um, and we can do more examples of this, but I'll go back up and show you what I mean by scale factor squared. That's kind of sloppy, but let's go ahead and make that a little easier to read. Okay, so what I mean by that is if I go back up to the top and I look at this first example, we can see that 10 times 2 is equal to 20, right? So 10 multiplied by 2 equals 20. However, 2 squared, so this is what this will look like. 6 times 2 squared, which is 4, okay, equals 24. Okay? All right, so let's look, and I'm going to box this so you can see where I've made my changes. Okay, so then let's look at this next one here. And my scale factor was 4, so 16 times 4 is 64, right? But 15 times 16, or 15 multiplied by 4 squared, is equal to 240. Okay, so what's happening here is that it's scale factor squared. Okay, so I'm going to write this as SF, and then this one I'll write as SF squared. Okay, let's look at another one. So this example here says scale factor was 1/3, which means a reduction. Well, we know 24 times 1/3 is 8. 1/3 is my scale factor, so I'm going to label that scale factor like that. But then this was 1/9, which is equivalent to 1/3 squared, or scale factor squared. In fact, let me show you. 1/3 squared equals 1/9. Okay, so hopefully that helps as you're going through this, the rest of this exploration. But once again, if you're lost, pause, rewind, watch it again, ask your sub for help, or send a message to me so you can go for tutorials later. Hopefully this is helpful. And then what I want you to do is complete 5, 6, and then answer these questions here. Just a reflection. Remember, if the scale factor is less than 1, what happens? If the scale factor is greater than 1, what happens? Okay. Based on what I've just explained about what happens with scale factor and perimeter, what happens? And then what happens with area? Okay, so just remember, just a hint, this one's scale factor, this one's scale factor squared. Okay, and then the last thing is the extra practice. So on questions 1 through 6, you're going to answer each question with a correct choice from the bank below. This is the bank. So then you're going to say, well, a figure is dilated by a scale factor of 6. What factor will the perimeter change? Okay, so what happens when we multiply by scale factor? It's for perimeter, it stays the same. So this one would be 6. But if we had the scale factor of 5, is the area multiplied by 5 or is it by 25? That's what I want you to think about. So I want you to go through those and pay attention to those details, okay? So that concludes the lesson for dilations and area and perimeter. If you have any questions, once again, send me a message, ask for tutorials, double check with the sub, but you should be good to go, okay? So I'll see you guys on Wednesday and have a good day. Okay, bye-bye.